this looks at trigonometric equations and general solutions. So if we have cos theta equals 0.819, we can solve that using a calculator by using the inverse cos function. But however, the calculator will only give us one solution. And you know from the graph, because of the way the cos graph goes on to infinity, there's an infinite number of possible outcomes. We can use the symmetry of the graphs to find what are called general solutions. So we can find a function that we can substitute in that will give us all possible solutions if we want them. So for equations involving cos, if you look at the cos graph, if this is a solution, then in the same place on each curve is also a solution, and they differ by 360 degrees. So we've got a solution plus any number of multiples of 360, or if we're in radians, 2 pi radians. We've also got this solution, and this solution will be the negative of that solution, and then that one is also plus any multiple of 360 degrees or 2 pi radians. So the method is to use the calculator to find the first solution, so this one, and then we know that we can have plus or minus, and then we add on any multiple of 360 because it takes us to the next sort of part of the curve. So in degrees, for an equation involving cos, theta will be 360n plus or minus alpha, where alpha is the solution that the calculator gave us. If we wanted it in radians, the only difference was instead of 360 degrees, we've got 2 pi radians, otherwise it's the same. So for example, if we want to find in degrees a general solution of the equation cos theta equals minus 0.7, we use the calculator. So inverse cos of minus 0.7 is 134.4 degrees, and then we just substitute into the general solution. So theta will be 360 times n plus or minus 134.4 degrees, and n can be any integer. In equations involving sine, again the steps are the same. We use inverse sine to find the first solution, which will be this one, and then that solution there with the cross will be 180 minus that solution, and then because of the way the graph works and we've got a repeating pattern every 360 degrees, we will have 360n plus alpha, which will be that one, or 360n plus 180 minus alpha, which will be those ones for the red crosses. In radians, just 360 will become 2 pi and the 180 will become pi. So we've got two solutions for sine, whereas the two solutions, the two different ones we could put together with the plus or minus here, it's harder for sine. We've got theta is 360n plus alpha, or theta is 360n plus 180 minus alpha. In degrees, in radians, we've got theta is 2 pi n plus alpha, or 2 pi n plus pi minus alpha. We can combine them into this formula, so it's 180n plus minus 1 to the n times alpha. So if n is odd, then we get 100, so if n is 1, we get 180 minus the alpha. That's like this one where n is 0, and we just get 180 minus alpha, which would be that red cross. If n was even, we get 180 times n, which is an even number, so that will be a multiple of 360, and then minus 1 to the power of an even number will be 1, so that will be linked with the 360n plus alpha. And then the same in radians, the 180 just becomes pi. an example of this is here, to find the general solution of the equation sine theta equals negative 0.4. So find the first solution and we get negative 23.6 from the calculator. So the general solution is 360n minus 23.6 degrees, or 360n plus 203.6 degrees. That 203.6 comes from the 180 minus alpha, so it's the 180 minus 23.6. Or if we wanted it as one solution, it'll be 180n minus 1 to the n times 23.6 degrees. Equations involving tan are slightly easier in that it's sort of one repeating pattern every 180 degrees or every pi radians. So again, we use a calculator to find the first solution, alpha, using the inverse tan button. And then the general solution will just be our alpha plus however many lots of 180 we had. So it's 180n plus alpha in degrees, or pi n plus alpha in radians. So in this example, find in radians the general solution of the equation tan theta equals 1, using the calculator to get our first solution. Inverse tan of 1 is pi by 4, so just substituting that in for alpha, we get theta is pi n plus pi by 4.